Now, why would we care about learning about all of these different things? I'll give you some of the reasons. When you study biology and you're trying to understand the way that animals work, the way we think, the way that we behave, you start to see that everything happens at the molecular level. That's the chemistry of the way the molecules interact with each other that actually makes life exist. And life is not much more than molecules talking to each other. But molecules are built of atoms, and so it wasn't until we understood the atom that we understood chemistry, which is how molecules interact with each other. But atoms are made of particles, subatomic particles like protons, neutrons, and electrons. And until you understood that, we weren't able to master nuclear physics and things like the nuclear bomb or nuclear power. And then we understood that those particles will make us makes of particles even, like the quarks, for example. And we also understood different properties of these molecules, the way they spin, the way they orbit, the way they act in relationship to each other. Helping us understand the standard model of particle physics help us make other advancements. For example, semiconductors and superconductors, which we use all over in modern technology, including computers, wouldn't be possible if it wasn't for our understanding of the way that these tiny little particles work and interact with each other. And now think of other applications, for example. What if you were to find the Higgs boson and find a way to neutralize it, so that you can delete the mass of anything that has mass, or basically cancel the mass, or tell the universe that that thing did not have mass. Basically cut the cords between the Higgs boson and whatever mass actually is. When you do that, you basically make the particle like a photon, and therefore capable of accelerating to the speed of light. So faster than light travel, the key to that might be in finding and isolating and breaking the Higgs boson. Likewise, if we ever want to actually study the way that quarks actually are and interact with each other and then kind of create new kinds of matter, the best way to do that is to play with those other bosons like the gluons and the W and Z bosons, which mediate the weak and the strong force. And so it's understanding those bosons that actually help us create things like better atomic bombs, better nuclear reactors, and perhaps the energy of the future, which is going to be controlling matter-antimatter collisions at the quantum level. What about the photon? Mastery of the photon might actually help us understand how to create faster than light speed travel, how to increase communication capacity. Mastering the photon helps us create, for example, the photovoltaic cells, fiber optics. It helps us understand a lot of the things that electromagnetism does and what it is. And finally, a particle like the graviton, which is not even included in this standard model design here, mastering the graviton would help us break gravity and maybe manipulate gravity to increase it or decrease it at will, creating things like anti-levitation devices, or making us be able to bend the space-time continuum the way gravity does, and perhaps bend it so much that we can create our own black holes and our own singularity events, to maybe create things like wormholes to connect us to distant points of the universe and cheat the speed of light without actually breaking it. Applications like time travel, like faster than light speed travel, like ultimate infinite generation of power. All of these things might be dreams right now, but they're actually might become a reality the same way that going to the moon became a reality once we were able to understand things like relativity. If we actually understand and fully master quantum physics, we can actually expand the limits of what science is capable of doing. So why do we study this? Because we want to do more. And we want to be just like the bosons. We want to be just like the fermions. We want to be somewhere and be able to do something. And to do that, we have to understand how the universe works in order to predict it and then to try to control it. You may call it trying to play God, but scientists calls it trying to understand, trying to expand the limits of imagination to the point that you actually create your reality. So in true quantum physics fashion, reality is what we actually observe of it. So the more we study and learn about it, the more we'll be able to create the reality that we want. The more we're able to understand the way the universe works and actually make it work the way we want it to work. In other words, the extent of possibilities is limited only by our imagination.